A little bit about me. My name is Hans Doctor. I'm the founder of Gradle and the CEO of Gradleware. And I would like to explain our current roadmap for the next 6 to 12 months, why we have decided to focus on certain features, what will be our release strategy, a little bit about the long-term vision, and I'm very interested in your feedback. So at the very end of the webinar, we will have 5 to 10 minutes, or basically as long as we want to further dive into topics that you want to talk about, etc. But you can ask questions all along every slide, and I try to answer them at an appropriate point in time. So yes, and now let's dive into this webinar. So we consider Gradle 1.0 as a steep evolution in the Java build system space, and I would say in the build system space in general. I don't consider it a revolution, right? So it combines the best of Ant and Maven, so the flexibility of Ant built by convention by Maven, and the whole idea of adding more high-level abstractions. And on top of that, it has a lot of innovations, incremental build, the wrapper, the daemon, many features we like very much, and we think there are those are deep engineering feats that add a lot of quality to the Gradle build system compared to the alternatives. Nonetheless, Gradle 1.0 is covering the classical build domain, at least has a strong focus on that. So it is mostly still a build tool. Of course, you can use the low-level um, execution layer of Gradle to automate everything, the whole continuous delivery pipeline. But the real domain modeling, where you get a lot of high-value abstractions, this is so far they are mostly centered around the classical build domain. And we are very proud on that achievement. So the fact that it's not a revolution but a steep evolution means something to us. That we spend a lot of work into that, and we will continue along that line. So there will be continuous improvements. In fact, they should be made available every 6 weeks. So our release strategy is that after a release, 4 weeks after a release, you will get a new release candidate. We don't know how long this release candidate will live, whether there will be a second one or a third one. We expect that after 1 or 2 weeks after a release candidate, there will be the actual release, but that, of course, that's not completely plannable. But what is plannable is that 4 weeks after a release, there will be a new release candidate. So we practice what we preach, doing continuous delivery, and trying to release frequently, release early, get early feedback from the community, and provide new features also very early to our users. So one aspect of frequent releases with the build system is that it is a rather conservative domain. So which makes sense. A build has a high leverage, and it's something different to, let's say, upgrade a mocking library for unit tests than upgrade to a new build system, or even just a new version of a build system. So to kind of combine our frequent release strategy with the quality and the security you need in the build system area, we are working on a build migration plugin. And there's also a design document on that. You can find it in our GitHub repository with the link above. And the idea is there are a couple of migration paths, right? You want to upgrade from one Gradle version to another, or you might just want to change your build environment. So you stick with the Gradle version, but you change the JVM arcs or whatever setting you have. Or of course, you want to migrate from N to Gradle, from Maven to Gradle, or from a custom build to Gradle. Those are possible migration paths we try to support. And in the first version of this migration plugin, what we are going to offer is that this migration plugin will help you to compare the build output. So from a Gradle to Gradle migration, that will basically just work out of the box. So Gradle will figure out what are the outputs uh, of that particular build, and then just compares whether the output is still the same. And that's the most important part of that. I mean, after all, the outputs of your build are the artifacts that end up in production, so you want to make sure that they are the same. We will then further continue to improve that. So not just comparing the build outputs, but also comparing the performance between two different versions of Gradle. That is only so the performance comparison is only really interesting if you do a Gradle to Gradle migration. And we will also compare the memory consumption. So with all that information, you have a extremely high likelihood, if the reports showing that there are no problems, that you can safely upgrade to a new Gradle version. And on the other hand, for us, this is really great stuff. Basically, our users, they are our manual testing team. So once we announce the next release candidate and the migration plugin would be available, we would ask our users, hey, can you try it out with the migration plugin? And we would get a really detailed, in-depth testing reports if something is going wrong, and problems will be detected very early. So that will also, I think, contribute a lot to the quality of the Gradle build system, and to find problems very, very early if they exist. In any case, Gradle will be backwards compatible. I mean, that's the major promise of the 1.0 release, but it won't be backwards compatibility for eternity, right? So we are following a similar approach like Spring Source had. When we think there's a better way to solve a particular problem, we will deprecate the old way. We won't remove it. We will deprecate it, and then with a long period of notice, at one point in one upcoming major release, the next one or the one after the next one, this feature will be removed. So there will be our approach is approach of control change. The reason why we do that, at one point we want to kind of get rid of some dead weight in Gradle if we have found a better way of doing that, and it also will make the learning Gradle much easier if there's not over the years 5 different ways of doing things. But it will be, as I said, a process of control change. And of course, you can always stick with the old version if you're in a very constrained environment, and if you really need, you could also then ask Gradleware to backport certain bugs, etc. But usually that I don't think that will be a requirement. So along this continuous improvement story, we have separate buckets. We put our issues in. So one category or several category of buckets. One is we say it's bugs, it's pain, it's joy. So of course we will continuously fix old bugs and probably also new one. And then there is pain in Gradle at the moment. There are some things where Gradle should make it easier to solve them, like applying external plugins or testing plugins. Or there's a longer list, and there is stuff that we consider as joy, stuff that people wouldn't necessarily expect, features that people wouldn't necessarily expect, but once they are there, they will love them. The other category of buckets is more domain oriented. So we have a performance bucket, IDE integration bucket, usability bucket, core features, error reporting, dependency management, and reporting, and a few more. And our idea is basically to have in each release at least one or two stories for each of those buckets. So as an example, certain stuff we are planning, high level build avoidance. So we want to do stuff that when we figure out that the class path has changed, we want to do a more in-depth analysis whether this change needs to trigger a recompile. It might just be a change in the implementation of a method, and then we don't need to recompile against that. So we would check the public signature of the jar to see if something has changed. So I think that's a really cool feature. People wouldn't necessarily expect it. So we consider this a kind of joy thing. And of course, it would also add to the performance bucket. So Peter Niederwieser just improved our test logging DSL. You have now a really nice DSL to exactly describe what test logging should be sticky on the console. At the moment, Gradle just says test has succeeded or passed and or failed, and only the fact that a test has failed is sticky on the console output. And with this test logging DSL, you have now full control. We also have an experimental branch for a C native client. So at the moment, when you use Gradle with the daemon, you have the long-running daemon JVM, and when you start a Gradle build, a client JVM fires up and then communicates with the long-running Gradle daemon. But this firing up of the client JVM is depending on the state of the machine, on how fast your machine is something between 300 and 800 milliseconds. So with a C native client, this is just the whole feeling of responsiveness is much better. I mean, it's not a big deal for CI build, but as a developer or as a build master using Gradle very, very frequently in a command line, that's just nice when a tool is as responsive as it can be. So that's for example what we also consider as usability and joy. Nothing, no killer feature, nothing that is something you would necessarily need, but nonetheless something that many people will appreciate. There's a side plugin, there's a full programmatic cache control, full programmatic resolve control in the area of dependency management, CI management. We want to make it very easy to configure your Hudson jobs, not via the Hudson UI, but also via the Gradle DSL. Plugin testing, that's at the moment quite a pain. So that's something we want to address in the pain bucket. Content assist in the IDE, that's also, I would say, a little bit of the pain. People in the Java world expect just a smart IDE that gives good content assist. So when you configure a Gradle task, you would expect that the IDE will tell you about the configuration options. That is not possible at the moment, but that's something we're working on. And another example would be SBT Scala integration, which is which solves the pain of the long-running Scala compile time in Gradle. So those are examples and stuff we will continue to work on. Of course, there are many more issues, but just to give you an idea. So there are some other new big build features. So still features that belong to the classical build domain, full C++ support. We have already not a bad C++ support, but it's not full blown. We don't offer incremental compile yet, and no parallel compile. So that stuff we're working on, and a little bit more. We will talk about it later. We also started to work intensely on JavaScript support. So that's another platform we want to, where we have the goal that Gradle becomes the best platform for building JavaScript project. iOS and Xcode is another platform we want to support, and Android as well. So there is a lot to do in the classical build domain. Work for years to make Gradle simply a better and an excellent build tool that is fun and enjoy to work with. But let me ask that question. So let's say you have now this most excellent build tool plus the existing ecosystem, like having Jenkins, a binary repository manager, etc., etc. Is that good enough to solve the current problems in continuous delivery? Um, in my opinion, this is not good enough. So we, as Gradleware, we are involved with a significant number of medium and also very large enterprise builds, and we encounter a lot of problems there. Mostly, it's the whole learning, collaboration, promotion process across teams. So we are involved with projects where 500 developers work on one year, and they have 50 components, 20 teams distributed across Europe, Northern America, and in India, and 15-year-old legacy application, 20 million lines of code, C++ and Java, etc., etc. So those projects have significant problems in a variety of areas. So one of the biggest problem is feedback time. So they build easily takes 12 hours, 18 hours, and it's very hard to develop successfully software with such a large feedback time, let alone feedback time when you're doing local builds. What is also extremely hard with those projects is that exploratory learning, I borrowed this term from lean software development, is very hard. And I think a lot of the exploratory learning you want to do in such projects requires very good automation. So let me give an example. Especially those legacy projects, they have accumulated huge technical debt. So ambitious refactorings are often very necessary to keep the software alive. On the other hand, it is so hard in those enterprise environments we have encountered to get any feedback when you're doing changes to your local working copy, and then you want to learn, hey, how does this affect dependencies that are downstream, which means dependencies that depend on my changes, right? So you want to have an easy way to ask questions like, hey, let's see if I've broken any of the downstream UI products, or you want to do an ambitious refactoring, and there are some teams opposed to your plans, and they're just waiting that you get into trouble. So you want to make very sure when you play around with your changes to validate that you, in particular, haven't broken any of their stuff, right? That their projects still work fine with you. And there are many questions you want to ask regarding your changes and how they affect other components, other released components, or the latest from source of those components, etc., etc. A variant of that is cross-team collaboration, right? Let's say you work in a team, and your usual mechanism is that components depend only on released versions of other components, but then for some very ambitious feature, you want to collaborate more closely with the team that depends on your stuff. It should be extremely easy to instruct your build system and your automation system to say, okay, I want to parameterize that for this local build. Don't use the latest release version, use the latest from source. And this should be possible from your dirty working copy, not just on CI. Of course, you can answer all these questions by manually setting your local environment up, right? You can check out the projects you're interested in, then you can rewire the build. That might be quite a lot of work depending on the build system you're using, so that it shouldn't use binaries but should use the latest from source, etc., etc. And basically you want to ask these questions daily and possibly many times, and when it's hard to set them up, you don't ask them, or at least there will be orders of magnitudes less situations where you ask them. That's my experience. So it should be extremely easy to do that. And the bigger the project, the more challenging it is to ask those questions, and the more time consuming it is to set it up manually and locally to ask those questions. Another big problem we have encountered is a continuous feature flow to downstream teams, like manual testing. So many big enterprise builds, they practice CI, and then so to get early feedback when their components don't collaborate. But at the end of the day, there is a software stack made out of those components, and this software stack is needed by the downstream teams at the end of the day by your client, so to be used, right? And in many cases, we've seen situations where it took a company days or even weeks to get at least the next working version of the complete software stack that can be tested, and that's a serious problem. So you get you don't utilize your testing team, you get feedback very late, and according to that, fixing stuff out of this feedback, it becomes very expensive, etc., etc. So continuous integration is good, but continuous delivery is not just about continuous integration; it's much more. And we often see a problem on this continuous feature flow to downstream teams. So to model this feature flow and enable this feature flow, you need strong gates on all levels, and you need a language that you can use to describe those gates. At what point certain code should be exposed to the next layer in your enterprise, and what are the criteria for that. Another thing that we want to make more convenient for the enterprise is platform testing, so that it's really easy to, with some distributed mechanism, to use all different kinds of machines and platforms to test your stuff. So the status quo, we think no current tool chain solves those issues conveniently. We know a few enterprises that have a good solution for that, but they, on the one hand, they had an excellent continuous delivery team with outstanding people, and they invested a lot of resources. They invested a lot in basically developing on top of Ant or some other tooling their own enterprise build system. So it was very expensive to get there. And our goal is to provide a Gradle toolkit that makes it as easy as possible to capture this complexity in the enterprise and provide the functionality and solutions for the problem I described above. And our strong opinion is that this solution shouldn't be some click UI product, but it should be based on a rich language that is really capable of capturing the complexity of such an automation domain. So you may ask the question, what is more important, to make it to make automation as easy for projects like Commons logging or for the 500 developer legacy build? And our focus is the pain in the medium to large scale enterprise builds, and that affects to some degree our priorities. So for example, if you ask us, what is more important, a Gradle site plugin, which we would love to have, but it's not there, or a parallel and distributed build feature, we would go for the latter, right? If our goal would be to be the most used build system for, let's say, smaller open source projects, and just to get maximum adoption and user base, our prioritization might be different. But we think the biggest contribution we can do for software development is in the enterprise area. And of course, we will improve Gradle across all aspects of what a build tool should do. And we're also looking forward to that the community contributions we're getting will continue. But our focus is as I've just described. So what does it mean in terms of features? So one problem we have currently with Gradle is the configuration time when you have larger multi-module builds. So our record holder is a legacy project with 800 submodules. Whether this is a good idea or not to have so many submodules is a different question, but it's the reality for them at a particular moment in time. And especially for legacy projects, when they are either don't have enough components, it's not modularized enough, or went the other opposite and over componentized their software stack. Changing this is a pretty serious refactoring. So you should have a good automation in place that can deal with the current status quo, so that you get all the necessary feedback to safely refactor towards a better architecture. So, and when you have 800 submodules, the Gradle configuration time, depending on the machine you have, might take a minute. I mean, it's pretty extreme corner case, but nonetheless. So, I mean, they are very happy that they have switched to Gradle, because they got their average build time down from a couple of hours to 15 minutes. But nonetheless, this is still an existing pain, the configuration time. So we want to do something for that, and starting with just basic profiling and increasing the raw performance of Gradle in that area, and then also do incremental configuration. So if a project hasn't changed, why evaluate the build script if the artifacts of the project haven't changed, or I mean the source hasn't changed. Another thing we can do is to use parallelization, so that we configure projects in parallel at the same time. So again, this feature is a pain for very large builds, but even for the Gradle build, I don't mind if that 1 second hiccup we already have for the configuration time goes away. Another topic that is very important to us is fluid multi-module builds. At the moment, we like our multi-module build, but it has certain constraints that make it hard to use in certain enterprise environments. So if you have many components, like the 500 development project I described before, many large components, the teams, they usually check out only one component or two, depending on how many they are working on. So and they're using version control systems, for example, ClearCase. If they would check out all components, the time to do an update would just kill them. And we've even with Subversion, we've seen projects when SVN update takes 15 minutes. So there's a scalability problem here. And it's also there's also a mapping problem to the IDE. The IDEs also don't work very good with many components. So at the end of the day, if you want to be able to connect the whole component graph in the enterprise as a build tool, you can't make as a requirement that every one of those components need to be checked out to your local machine. So we want to make it very easy to describe that you have a dependency on a component, but it doesn't need to be checked out by yourself. And we want to make it very easy to enable a quick switching between binary and source dependencies. So the current distinguishment we have between external and project dependencies, we will add further abstractions to that, because in one setting, what is a binary dependency is in another setting a source dependency and should be rebuilt. So at the same time, we want to provide something like a global project or component registry for the enterprise, or for whatever granularity your organization has. And there's a lot of smartness we want to do, even if you depend on source dependencies, right? We would figure out, and you would trigger a local build to build against the latest from source of a certain component. We would do checks like, hey, maybe on CI, or maybe on some other local build, someone has already exactly built that state in version control, and the binary is already in the cache, so just reuse it. This would also solve the problem of aggregate multi-module builds, which is also not so conveniently possible in Gradle at the moment. Yeah. The next big story for us is parallel and distributed builds. I mean, obviously, parallel build is just good to have. I mean, at the moment, Gradle doesn't have parallel builds, only parallel testing, and we want to change that. The reason, I mean, there would have been a very simple and cheap way for us enabling a multi-threaded build, and then saying, okay, users, Gradle is now able to do multi-threaded builds, but you have to take care that your build logic is thread safe and all that stuff. So it would have been a pretty fragile thing. So So we want to provide a parallel build where basically you as a user don't need to worry about concurrency issues. That Gradle should just take care of that. And our approach will be not a multi-threaded build, but a multi-process build. And yeah, we are very much looking forward to that. So and because for parallelization we already use multi-process, going distributed is then not such a big step, especially if you reuse certain tools that are already out there. So why do we want to do that? I mean, the most important reason is performance, and the fantastic benefit that this offers, if this is offered by a build tool and not by CI, is that you can use that from a local build. So you can use your dirty local working copy uh, and still use the build farm you have in the enterprise to get a very fast feedback. So for all the stuff I talked about, like exploratory learning and team collaboration, getting this feedback very fast would be fantastic. And the other aspect is when you have multiple platforms to work with. So uh, um, if Gradle is able to work with distributed machines, you can do a C++ build of a certain library and trigger it with one go, and Gradle will build it all on all the different platforms where you need the binaries for. Uh, Another very important use case is distributed integration testing. This is stuff to some degree you can already solve with Jenkins, but not as conveniently, by far not as conveniently as what you can do if you can describe that with a rich build language. We might even interact with Jenkins to provide some of this functionality, but at the end of the day, we would provide you a rich DSL to describe that. And however we then implement the distributed execution bit is an implementation detail. But it's all version controlled, nothing to be set up on a UI, and all available also for your local build. Another thing we are pretty excited about is variant-aware dependency management. So when you think about the current dependency management paradigm, uh, describes an artifact via its group, via its name, via its version, right? But if you look at other platforms, that's not all the information you actually need. For C++, you have a platform aspect, architecture aspect, 32 or 64-bit, etc., etc. So you have basically one library, but you need to specify more than just a group artifact version. You also need to specify for which platform is that. JavaScript, similar problem, minified versus non-minified, for example. Scala has a lot of issues with binary backwards incompatibility. So you need many Scala libraries for different versions of the Scala runtime. But even in Java, you have libraries now that Java has started to innovate again, uh, where you have a JDK 7 version or Java 7 version that makes use of new library features that are not available in Java 6. So and with the POM, for example, there is not a really good way to express that. You could think, I might use the classifier, but those libraries, they have different sources, they might have different Java docs, etc. So there's no good way to express this. And we thinking about some enhancement to the existing metadata standards so that you can express this and make it also very easy as a person who produces these libraries to let them build. So for example, in the case of C++, you would just specify, hey, this is my library, those are my variants, now Gradle build it. And with all the distributed stuff I've talked before, right, Gradle would produce all the binaries you need. The same is true for the other platforms I've talked about. So we're pretty excited about what we plan in this area. A deep Maven import is another thing we want to have. So it's similar to the deep and import we provide already. It would even go that far that POM.XML would be accepted as a native build descriptor by Gradle if there's no build.gradle available. And the idea is to integrate easily with Maven legacy builds, or to enrich existing Maven builds with additional functionality you get from Gradle, like incremental build, etc., and to reuse existing Maven plugins. Another thing we want to improve is plugin portal and plugin development. So we need a better plugin portal than our current wiki page. There's no question. We want to have a nice web portal with community features where you can vote, where you can comment, where we would have a nightly build that checks all the plugins, whether they are still running successfully against the latest Gradle from source. We want to make it easier to test plugins. We want to make it easier to use external plugins, and we want to make it easier to publish external plugins. So what we get now and then is that a company is in need of a certain feature, and we had quite a couple of successful engagements where the company said, okay, we really need that, so they paid us for prioritizing certain functionality, which was anyhow on our roadmap. We wouldn't add stuff that doesn't make sense for the Gradle open source build system. But if we think, hey, this is stuff we want to have anyhow, and we get paid R&D for that, well, then let's do it. We might as well do it right now. So this is stuff that somehow kind of changes our priorities, but it has to fit with our strategic goals, and at the end of the day, it accelerates the development of Gradle because we just have more resources to work on a Gradle open source technology. So this is great stuff. So that's all from my side, and now I'm very interested in your questions. There are already 2 questions. Sorry, I missed them initially, so I just read them out loud. And please continue to file your questions. Ivy had a very good reporting page generated when run, showing what jobs were in conflict, which were selected, and why. This was very handy when you got a version you weren't expecting. Are there any plans for Gradle to provide similar functionality for large, complex applications? This feature is quite helpful. This is from Douglas. Yes, Douglas, absolutely. We are planning this, and there you can expect something pretty soon, I think, to give you a very good idea where the conflicts are, what were the available release candidates, and for which release candidate, what were the available candidates for resolving the conflict, and then for which candidate Gradle finally decided to vote for. So yes, this is missing in Gradle, and it would be really helpful to have that, and we are planning to add that soon. Next question, is there a tool to migrate M3 POM.XML to Gradle build.gradle? There is a tool, it's an external plugin. It's called the Maven to Gradle converter, and it does a decent job in converting the basics of a POM.XML. So if you ever manually converted a POM.XML to Gradle, it's a pain in the neck to manually rewrite all the dependency notation. So this tool basically configures the Gradle for the standard Maven plugins, and it converts the dependency notation. If you used any custom plugins in your Maven build, they would get ignored for now. But there is a tool, and it is helpful. And we want to add this tool to the core very soon, and then we want to improve it. Given that this is a roadmap discussion, can you map some of these things talked about to actual releases? Maybe just what we can expect for 1.1. So 1.1 will be pretty soon, 4 weeks after our 1.0 release. So yeah, in basically less than 2 weeks. So we have a lot of bug fixes in there. So this is just, there's nothing spectacular in there. We might have a first version of the migration plugin there. Otherwise, from all the features I've talked about, there will be nothing in 1.1. So if you go to the Gradle roadmap, it's still to gradle.org/roadmap. It's still work in progress, but we in general we decided not to bind it to certain version numbers. It's just a promise we often can't stick to. It's not how we develop. We have we don't have always a constant stream of resources. That's the nature of our project. It's depends on the amount of community contributions we get. It depends how many of our people at the client side. So it's very hard to make promises in regard to that. So the only what we have done regarding our roadmap, we now have two roadmaps. One is really what we plan for the next 6 to 12 months, and the other is the long-term vision. Before that, it was just one roadmap that presented work for the next 3 years. So we kind of tried to make the message a little bit sharper. But then I think the only thing that really counts if you go to the roadmap and you can see this is in progress. I think that's the only truth. When this is in progress, we actually start developing that. Otherwise, we're just too afraid that we make wrong promises and disappoint people. I mean, if you are interested in a particular feature, you can always ask on the forum what our specific plans, and then we might know or we might not know in terms of version. We just say this will be before Gradle 2.0, right? But that's all we know at that point. Are there any plans to implement a Kerberos authenticated dependency resolver? Yes, there are. So the Burr is working on that. At least did some spike. So I don't know what the current situation is. I would need to ask Des. So yeah. So just ask that question in the forum. Next question, was there an update on a Maven release-like plugin for Gradle? There is an external plugin that has a similar functionality. So then the Maven release plugin, I've never used it in anger. So I can't say much more to that. What I mean, when we're talking about a release plugin, it's we see for a real release plugin, we see a much larger scope. It has a lot to do with build promotion, with modeling the gates, etc., not just doing some text and version control and checking the dependency metadata for dynamic revisions. But if you're going for this stuff, have a look at our plugin wiki page. There is a release plugin for Gradle that does something similar. Are there plans to support Eclipse projects outside of making them part of multi-project build? Currently, we have to custom modify the Eclipse classpath file to reference those projects directly. Yes, good point. The SDS guys just have asked us this feature, that people were asking this in the SDS screencast on the Gradle usage. So this is something we're communicating with them, so we are aware that this is an important use case. That's all I can say for now. It hasn't, we haven't started any detailed planning on that. Is there a video tutorial series planned down the line to complement the book for Gradle? So we plan a set of screencasts, but more like 5 to 10 minute screencasts. So which are more kind of trying to get people excited and showing them some cool stuff than being a real training video. I mean, I know O'Reilly is offering this, so we have had some thoughts on that, but nothing is planned yet. But it's interesting that people are interested in that. It's good to know. Where does distributed parallel build fall in the priority list? 1.1, 1.2, some date. I'd like to take advantage of Jenkins build farm to dive out native CC++ and Java builds on different machines. This is high priority. So it's definitely not 1.1, and it will initially be added as an experimental feature, right? Where we say, hey, the DSL is not stable, use it. The code quality will be reasonable, but don't expect it to be stable, and then get your feedback and make it more and more production ready until we say, yes, this is a stable feature in Gradle. It's high on the list, so I hope we can show the first features in 1.2. Can you discuss what participation you expect from the community? This is a very good question. Um, so there, I mean, where should I start? Uh, so one is definitely trying out early versions of Gradle, giving feedback, commenting on the roadmap, etc., etc. And then, of course, we would love to see, as many contributions as possible. Although we also respect the fact that we don't make it as easy as it could be. It's not, we don't have a good plugin portal at the moment, so the motivation would be much higher to contribute if it's very easy for other people to consume what you have contributed. So there's a lot of stuff I think we can do to embrace I think the really cool community we have, and that is high on our list of things to do. Um, and I also acknowledge the problem and the danger that with a professional open source project like we have. I mean, we all have strong open source background. Everyone that is working for Gradle, Mockito founder, Spock founder, Jeb, Grails committer, etc., etc. So we all have a strong open source background, and it's not just even a completely non-commercial one. But the danger is when you have a team uh, of employed Gradle core developers that you forget about to communicate a lot of the discussions you have with the community. So this is a danger. We sometimes fall into the trap, and we're trying to work very hard to be as transparent and communicative about our plans as possible. So that's something I'm trying to push very hard. For example, we have an internal list to discuss some stuff, and then we always say, hey, damn, this should have been discussed on a dev list, stuff like that. So, but we would definitely love to see contributions from the community in all areas, right? Patches, testing, ideas, joining the discussions on the dev list, etc. But what you also know, we have to make a strong effort to provide a fertile soil for that, and there's more we can do to make that more fun to participate in that project, starting with the plugin portal. So Des just responded. He said he's currently doing design on Kerberos support, and his design plan will be scheduled once design is complete, which will be very very soon. Thanks, Des, for letting me know. So, more questions. Great. Are there plans, or is there already a set of style guidelines or other recommendations for how to implement and structure Gradle plugin? Thanks to Groovy and the way the Gradle DSL is implemented, there seems to be many ways to do the same thing, so it seems like this may be helpful. Yes, very good point. I think the documentation on writing plugin could be much better. So the second part of the O'Reilly book will have a focus on this, and we're closely collaborating with Tim to lay out what we think are best practices. And then at one point when this book is done, this will be also then available as a free online HTML version. So it will be part of the Gradle documentation. Yeah, I definitely see your point, Douglas, with that question. And Luke Daly is now also working on a good presentation, or he has actually presented it at UberConf on advanced Gradle plugin development. So his slides with some little bit more narrative might be also a first step that is very helpful about what we think are best practices. Another thing you might rise again at the forums, and then Luke could point out where his slides are, etc. Where can you continue the conversation concerning how the plugin environment can be improved? The Gradle.org roadmap page is light on details, and the community will have a lot to say. Very good point. I will pick this up in a follow-up email to this webinar. So that was the last question for now. Okay, great. Thanks a lot for all your questions, for all your input. Yeah, that was the last slide. Thanks a lot for your attention, and I hope to see you at one of the upcoming conferences, Java One, Spring One, UberConf, Devox. I will be there at each of those, and so if you're there, just drop by at our booth and say hello. Otherwise, see you in the forums, and I wish you a very nice day.